Hello, my name is Akash Surikant Khode. Today I am here to present my third capstone project, Mobile Price Range Prediction, which is a supervised machine learning classification problem. So let's check the problem statement first. Mobile phones have become a necessity for every individual nowadays. People want more features and best specification in phone, and that too at a cheaper prices. Mobile phone comes in all sort of prices, features, specification and all. Price estimation and prediction is an important part of consumer strategy. Deciding on the correct price of product is very important for the market market and success of a product. A new product that has to be launched must have the correct price so that the consumer find it appropriate to buy the product. In the competitive mobile phone market, companies want to understand the sales data of mobile phones and factors which drive the prices. The objective is to find out some relation between features of a mobile phone, that is RAM, internal memory, front camera, etc., and its selling price. In this problem, we do not have to predict the actual price, but a price range indicating how high the price is. The main objective of this project is to build a model which will classify price range of mobile phones based on the specification of mobile phones. So next part is data description. We had a mobile data in which we had 2000 rows and 21 features including the target variable. So let's check the meaning of each column and its meaning. First column is battery power. This is the total energy a battery can store in one time measured in mAh. Bluetooth is whether the mobile is Bluetooth or not. Clock speed is speed at which microprocessor executes the instruction. Dual SIM is the column which indicates whether mobile is dual SIM or not. Front camera is nothing but front camera megapixels. 4G is whether the mobile is 4G or not. Internal memory is given in gigabytes. M depth is mobile depth in centimeter. Mobile weight is nothing but the weight of mobile phone. N cores is number of cores of processor. PC is the primary camera in megapixel. Pixel height and pixel width is the pixel resolution height and width. RAM is random access memory in megabytes. Screen height and screen width is the screen height and width of mobile in centimeter. Talk time is the longest time that a single battery charge will last. 3G is whether the mobile is 3G or not. Touchscreen is whether the mobile is a touchscreen or not. Wi-Fi is nothing but the whether mobile has Wi-Fi or not. And the last is nothing but our target variable, which is price range. This is the target variable with a value of 0, which indicates low cost, 1 indicates medium cost, 2 indicates high cost, and 3 indicates very high cost. This is the target variable, that is our dependent variable. So next part is data wrangling. While looking at the statistic of the data, we found that the pixel height and SC width, that is screen width, had a minimum value as 0. Here we can see, which is not possible practically. The mobile will have some width and pixels will have some height, so it is not possible to have 0 values. So first we found out how many values are there with these mismatch values, that is 0 values. So we found that in SC width 180 values were there with a 0 value, and in pixel height there were only 2 values. As there are only 2 values, so we drop this observation. This is not going to affect our modeling. So for the SC width, we use the KNN imputer method. First we replace the 0 values with NaN values. So the missing values are imputed using the, later we imputed using the k nearest neighbor approach, where a Euclidean distance is used to find the nearest neighbor. Here we can see we have successfully replaced the NaN values. So after handling the mismatch from the data, we checked for the missing values in our data. We found that there were 0 values in the data. and zero duplicates observation were found in the data. So next is we found the we checked the outliers in the numerical column and its distribution. These all are the distribution and the box plot for each numerical value. Here we can see pixel height and front camera uh, had some few outliers here, and the distribution for almost all numerical, it is normally distributed except the screen width and pixel height and front camera, it is slightly right skewed. So to handle these outliers we use the IQR method. Here we can see the box plot without outliers. We have successfully removed the outliers. So after handling the after handling the mismatch and the outliers, we started our EDA, that is exploratory data analysis. Here first we can see the different pie charts. This is the pie chart for our target variable. We can see here our target variable has equal number of observation for in each category, that is for low cost, medium cost, high cost and very high cost. Almost for every category 25% values are there. And next is the percentage distribution of mobiles having Bluetooth, dual SIM, 4G, Wi-Fi and touch screen are almost 50%. Here we can see the different pie charts for Bluetooth, dual SIM, 4G, 3G, Wi-Fi and screen. For Bluetooth, dual SIM, 4G, touch screen and Wi-Fi, the distribution is almost 50%. Very few mobiles do not have 4G. Here we can see 23.9% phones do not have 3G. This is the correlation matrix where we try to find out the relation between the independent variable and the target variable. Here we can see the RAM is has a strong positive correlation with the price range. Thus RAM increases, the price range also increases. Battery power also has a positive correlation with the price range. Here we can see it is 20% positively correlated with price range. Generally mobiles having high prices comes with the good battery power. Next we can see here the pixel height and pixel width are also moderately correlated with the price range, that is 15% and 16%. Generally high price range mobiles have good resolutions. Now we can see the 4G and 3G are correlated with each other with the 58% correlation. Similarly, nowadays we know that most of the smart mobiles has both type of options. This could be the reason that they are correlated. Next is primary camera and front camera are positively correlated. Here you can see it is almost 64% correlated, FC and PC. And screen height and screen width are positively correlated. Here we can see it is 46% correlated. Next is the these are the bar charts for the price range versus RAM and price range versus battery power, price range versus pixel height and price range versus pixel width. So mobiles having RAM more than 3000 MB falls under very high cost category. Here we can see the first bar plot in which red candle indicates the mobiles with very high cost category having RAM more than 3000 MB. As we saw, RAM increases, price also increases. We can see the increasing bars here. Mobiles having RAM less than 1000 MB falls under low cost category. This blue candle indicates the RAM having less than 100 MB. So mobiles with battery power more than 1300 mAh has very high cost. Here red candle indicates very high cost category with the power range more than 1300 mAh, and mobiles with battery power between 1200 and 13 mAh falls under medium and high cost category. Here we can see price range 1 and 2 has almost similar battery power range. Mobiles with more than 700 pixel height and width more than 1300 has very high cost category, falls under very high cost category. Here we can see the red candle indicates the pixel height more than 700, and in the pixel width, this red candle indicates the pixel width more than 1300. So next is the count of phones in each price range with the supported or not supported mobile specification. Here we can see there are different candles with the different colors. Blue is nothing but whether the mobile has Bluetooth or not. Mobile having Bluetooth. So we can observe that in each category there are equal number of mobile phones having both supporting and non-supporting specifications. This is the price range grouped by N cores and price range grouped by M depth. There are very few mobiles in range 0 and 1 with lesser number of cores. Here we can see category 0 and 1 has very less number of cores. This blue candle indicates the less number of cores. Most of the mobiles in price range 2 and 3 are with high number of cores. High number of cores is here we can see the red candle is having 4 cores. Number of phones with less thickness is high and count of phones with less thickness is low. Here we can see mobiles with less thickness is high. This is the different trends of price range versus other features. Here we can see the battery range versus price range. As the battery power is increasing, the price range is also increasing. Here we can see the clock speed for high price range. The clock speed is very less. Here we can see the front camera in category 2. The front camera is mobile have good front camera. Here we can see the as the price range is increasing, the internal memory is also increasing. For price range it is high, internal memory is high. Same goes with the pixel height, pixel width. Here we can see the RAM is having a good strong correlation with the price range. As the RAM is increasing, price range is also increasing. So this is the mobile with 3G and 4G features and mobiles with only 3G features. Count of mobiles with 3G and 4G with the both feature is high in very high cost category. This red candle we can see. Count of mobiles with only 3G features is high in high cost category. Here we can see the high cost category green candle. So the next part is model selection and evaluation. Before building a model, we performed the train test place. We kept 25% of the data for the test and remaining 75% of the data for training the model. We compared 6 algorithms and evaluated them based on the overall accuracy score and the recall of individual classes. Accuracy is the ratio of the total number of correct predictions and the total number of predictions. The recall is the measure of model correctly identifying the true positives. Following are the algorithms which we perform. First one is decision tree, second one is random forest classifier, third one is gradient boosting classifier, the fourth one is k nearest neighbor classifier, fifth one is XGBoost classifier, and sixth one is support vector machine. So next is evaluation of models. This is the evaluation table where we performed the all models with default parameters and after hyperparameter tuning. we check the accuracy score and the recall. Here we can see from this we can observe that the KNN perform very worst, so we highlighted it with red. So we can see the after hyperparameter tuning we got an accuracy score 76% on training set and 70.26% on test set. XGBoost is the second good model which gave the accuracy score of 100% on training set and 92.46% on test set, which is quite good. The best performance is given by the SVM after hyperparameter tuning, which gave 98.3% accuracy score on training set and 97.96% accuracy score on test set. Here we observed that the recall and accuracy is almost equal to each other. So these are the feature importances. Here we check the feature importance for each model. Here we can see the RAM, battery power, pixel width and height for each model contributed the most in the predicting the price range. This is the area under curves for each model. Here we can see the class 0 versus rest, class 0 1, class 1 versus rest, class 2 versus rest and class 3 versus rest. Here we can see the KNN performed very worst. We can see the area under curve is very less for the KNN, that is 80% and 78% for class 1. And we can see SVM gave the best result. We can see area under curve is almost 1 for each class. And one more thing we observed that there is a slight misclassification between class 1 and class 2. Here we can see this blue line and green line indicates there is a misclassification between both classes. So this is the final conclusions for our whole project. We started with the data understanding and data wrangling, basic EDA, where we found the relationship trends between price range and other independent variables. We selected the best feature for predictive modeling by using k-best feature selection method using chi-square test statistic. Implemented various classification algorithms, out of which SVM's algorithm gave the best performance after hyperparameter tuning with 98.3% training accuracy and 97% test accuracy. XGBoost is the second best model which gave the good performance after hyperparameter tuning with 100% train accuracy and 92.25% test accuracy score. KNN gave very worst model performance. We checked for the feature importances of each model, where RAM, battery power, pixel height and pixel width contributed the most while predicting the price range. So that's it from my side. Thank you.